Welcome back to the channel. In this video, we are looking at the convergence of a geometric series. So basically, you're just given a series. You need to be able to state whether or not it converges. Secondly, we are going to look at solving for the value of x for which a geometric series will converge. The bottom line with the convergence is that if a geometric series converges, its common ratio, it must be between -1 and 1, like I've shown in the highlighted area by the blue here. So let's look at the first part where we are given a series, and then we just need to state whether or not the series will converge. So in this example, or A rather, you are given firstly you are given this series. It is a geometric series. All you need to do is to determine or state whether or not the series will converge. Just like I've stated, all you need to do to determine whether or not the series will converge is to calculate your value of R. For this series, what is R? R is, we can do term 2 divided by term 1, which is basically 3. Or you could calculate it by 9 divided by 3, which is still 3. That will still be your R. However you calculate it, it's fine. So R is actually outside -1 and 1. It's not within that range. Therefore, the series does not converge. Reason is because R equals to 3. It lies outside. Yes, outside -1 and 1. That's why it will not converge. B, or not necessarily B, Roman figure 2. Suppose you are now given another series. 3, 1 plus 1 over 3 plus 1 over 9. Still the same question. Does the series converge or not? How do you do that? You still just calculate your value of R. In this case, it's simple. You can just calculate it as 1 over 3. Second term divided by the first term, or you could use that term divided by the second term. 1 over 3, is that a value between 1 and -1? 1 over 3, if you write it in decimal, you would realize that it is actually 0.33, which means it's actually between 1 and -1. Therefore, the series converges because R equals to 1 over 3. It lies within -1 to 1, that range. Then you are fine. Okay, let's look at another example. Roman figure 3. Suppose you're given the series 5 minus 2.5 plus 1.25 minus 0.625 plus ... to infinity. Again, the same question. Does the series converge or not? By now you know the game plan. What is -2.5 divided by 5? -2.5 divided by 5, it's actually -1 over 2, which is basically -0.5. -0.5, it's actually between -1 and 1. So therefore, the series converges because R equals to -1 over 2. It lies within -1 and 1. Sorry for the noise outside there. You know, we're not staying at a place where you have the tight teeth. Is the problem, but we move. Okay. Hopefully the noise is not that loud on your side, but we shall see. Moving on, you have another example where you are given the series as 2, 4, 18, 54. That's another series. Does it converge or not? You still just calculate your R. is just 6 over 2. It's a geometric series, it's given, so you don't need to prove that. Then your R, you get it as 3. 6 divided by 2, it's actually 3. You can check 54 divided by 18, you still get 3. So that's similar to the one that we had at the beginning, I think the very first question, where our R was 3. So the same conclusion will still apply. Therefore, the series does not converge because R equals to 3, it lies outside -1 and 1. Let's do, I think, 2 more. I'm sure you would have understood the whole process now. 4 plus 6 plus 9 plus 27 over 2 plus ... This is supposed to be a plus. Okay. So still, just calculate your R is 6 over 4. 6 over 4 is like 3 over 2, which is basically, what is 3 over 2? That is 1.5 if you write it in decimal form. So because it's outside 1 and -1, the series does not converge. The series does not converge because R equals to 1.5, it lies outside -1 and 1. Sorry for that. Okay, one last question. V I hate these Roman figures, but we move on nonetheless. 54, 36, 24, 16. Does this series converge? Again, you just need to calculate your R, which is a common ratio. 36 divided by 54. What is that? 36 divided by 54. When you punch on the calculator, you get 2 over 3, which is actually 0.67. 0.67, it lies within -1 and 1. Therefore, the series converges because R equals to 0.67, it lies within -1 and 1. Okay, let's move on to part B. Part B, in this case, you're just being asked to determine the value of x for which the series or the geometric series converges. Just determine the value of x for which the geometric series converges, then you're good to go. So this is the series, the first one that you are given. It's a geometric series. You have been told, now all that you are required to do is to get the value of x. No longer asked whether or not it converges. It's been told, it's been given to you that it actually does converge. So for it to converge, it means R is actually between -1 and 1. So what is R in this geometric series? R is x squared divided by x, and it's still between -1 and 1 because we are told that the series converges. So now for what will be our x for the series to converge, x will actually be between 1 and -1 because the x squared divided by x is just x. Then you are done with the question. Now you've solved for the value of x for which the series will converge. Secondly, or example 2, you are given the series 2x 6x squared plus 18x cubed plus 54x to the power 4 plus ... Okay, again, All you need to do is determine the value of x for which the series, or the geometric series rather, will converge or converges. Still, for the series to converge, the r has to be between -1 and 1, that common ratio for the series. What will be the common ratio for this series? Is 6x squared divided by 2x, like that. So now when we simplify, we get 3x, because 6x squared divided by 2x is 3x, and then now all you need to do is divide throughout by 3, so that we know what value of x will the series actually converge. We divide both sides, because the 3 that we divide with, it's actually positive. There's no need for the signs to face the opposite direction. So this is the value of x for which the series will converge. Part 3, another example. Suppose you are given the series, which is 3 over x squared minus 1 over x plus 1 over 3 minus x over 9 plus dot dot dot. It is a geometric series and it converges. You have been told that you don't need to prove it. So for which value of x will the series converge? Again, still for convergence, we know r has to be between -1 and 1. So because now you have quite a bit of two fractions throughout, I would advise that you calculate your your r separately, and then you can come back to this inequality and substitute. So let's look at how we can get r. R is going to be -1 over x divided by 3 over x squared. -1 over x, when you simplify, multiplied by x squared over 3. Basically, just change the division sign to multiplication sign, and then I flipped the two terms, numerator to denominator, denominator to numerator, on the far right. And then to simplify further, now you will see I have minus x squared over 3x. Then that cancels that, and then now you're left with minus x over 3. That is your r. Now that you have that, you can come back to this condition that for convergence your r should be between -1 and 1, and your r is actually -x over 3. So that -x over 3 should actually be between -1 and 1 for the series to converge. Then now you just need to multiply both sides by 3 to eliminate the denominator. To do that, you just do this, minus x minus 1. So x has to be between -1 and 1, but we are looking for x. So looking for x, now we have to divide throughout by -1. When you divide throughout by -1, the signs are going to change. The inequality signs, they are going to change the direction and then face the other direction. This is what will happen. So the series will actually converge if x is actually less than 3 and x is greater than -1. I hope that makes sense. That's how you read that inequality. Okay, assuming we are on the same side. Oh no, I didn't do the multiplication properly. On the right, I'm supposed to have sorry for that, 3 times 1, which is +3. Then this is becoming -3, like that. Sorry for the confusion. Okay, moving on. We have that. Which other? Now they just try to make it. Let's just try to make it a bit more interesting. We have the geometric series, like this one: x minus 1 cubed plus x minus 1 to the power 4 plus dot dot dot. So still we're being asked to get the value of x for which the series will converge. So because of the complexity, or how complex the whole geometric series looks like, it's advisable to start by getting the value of x, or the simplified version of r, before you go to the condition of the inequality. So how you get your r is like this. Just take term 2 divided by term 1, and then you try to simplify from here. You know x minus 1 is the squared is the same as x minus 1 times x minus 1. So you know that will cancel that, then you're left with x minus 1, that is your r. But for the series to converge, it's still, the condition did not change. r has to be between -1 and 1. Therefore, since r is x minus 1, that means x minus 1 still has to be between -1 and 1. Thus now your x is between, because now you just need to take 1 to either side, both sides actually. So this side is going to have 2, that side is 1 minus 1, which is 0. So for the series to converge, it means that your x has to be between 2 and 0, or between 0 and 2, however you'd like to put it, it's fine. Moving on to the last, is it the last example, or no, the second last example. They keep getting a bit interesting as we go. So you're given this one as your geometric series. You're still being asked the same question. 6 x minus 1 squared plus 18. Sorry for that. X minus 1 cubed plus 54. X minus 1 to the power 4. Okay, again, I would advise that you just start by calculating the value of r, or try to get the simplified version of r. So how you can get r still the same way: term 2 minus term 2 divided by term 1 rather, and then 6 divided by 2, that is 3. X squared, x minus 1 squared divided by x minus 1 is basically x minus 1, like that. That is your simplified version of r. So remember, you are still looking at the series converging, so the r must still be between -1 and 1. So since r is actually calculated as that 3 into x minus 1, so now you just need to divide throughout by 3. It's -1 over 3. That means you are left in the middle with 1 over 3. In the middle you are left with x minus 1. So move 1 to either side, both sides rather. So what are you left with if you do that? Moving 1 to both sides, okay, you're left with x in the middle, and then +1 minus 1 over 3, that gives you 2 over 3, and then 1 plus 1 over 3, that is 4 over 3. That's your value of x for which the series will converge. Okay, I think this will be the last example, then we stop. So this example, we are given the series, which is a bit complex than the previous ones. Plus 1 over x minus 1. Sorry for the handwriting. Okay, plus 1 over 3 plus x minus 1 over 9 plus ... So you see, one of the terms is actually 1 over 3. I think it makes life simple to just pick that one when you're trying to calculate your ratio. So we'll start by calculating the ratio. So this term divided by that, it makes everything a bit simple. So we're just gonna take that actually. So because to simplify 1 over 3 divided by 1 over x minus 1, it's better than, it's easier than to try to simplify 1 over x minus 1 squared. But that's not what I wanted to write actually. Basically, I wanted to say to you, to simplify this divided by that is better than simplifying this divided by this. Yeah, I hope you understand that. But well, it's just based on preference. Sometimes we have different ways of calculating this. So now you have x minus 1 divided by 3, that is your r. So once you have your r, you can come back to here, -1 and 1, and then x minus 1 is over 3. It's actually what your r is. So multiply throughout by 3, you get -3 that side. In the middle you're left with x minus 1, 3 on the other side. And then now, what is the solution? Just need to take -1, +1 to both sides. 1 minus 3 is -2, and then 3 plus 1 is 4. So that is your conclusion. I hope now you know how you can determine whether or not a series converges, and also be able to determine the value of x for which a series will converge. Thank you for watching. See you in another video.